what does manifest list basically consist of? Now, manifest list, what I told you, manifest list basically consists information with respect to the manifest files within it, right? And also it's related to the latest snapshot ID, correct? That's the two most important things. Now, when I queried upon this manifest list basically, and when I look upon the snapshot ID, what you can see over here, it's 5437 and it's ending with 546. And each of these data files within this manifest list is what? It's the same thing. If you look up over here, 5437, 546. So basically, this manifest list is related to the latest snapshot ID, and the manifest files within it is related to that particular manifest list, and those data files are related to those manifest files, right? Now, what we have seen, we have three manifest files over here, three records in the manifest file over here, right? And if you look at over here, added data files count. That means how many data files does this particular manifest file consist of? It consists of three data files, right? First data file, second data file, and the third data file. First data file is with respect to technology, and the next two are with respect to sales, right? And that's what it has stored. There are three data files that we have. Okay, existing data files count. So added is this one. Have we updated anything? No, right? Deleted data files count. Have we deleted anything? No, right? And what are the partitions? You see, you see, this one also consists of some type of kind of information that the manifest file record had. Basically contains none. We had it over here, over there, right? It does not contain null. This table doesn't contain null. Okay, this particular version of the table doesn't contain null. It contains a name. No. What is the lower bound and what is the upper bound? Let us just decode this one. Okay, when you decode this one, okay, this is the lower bound, all right? And if you decode this one, you get it as sales. So we have inserted sales into the business unit. It's the lower bound according to the manifest list. According to this manifest list, which consists of the latest snapshot ID information, right? And then if you go over here and just query upon it, sorry, sorry. Yeah. So the okay, so we have decoded it. It's technology basically, right? So the lowest lower bound is basically sales, and the upper bound is basically technology. That's what this manifest list basically consists of, right? So what it contains with respect to all those manifest files within the manifest list, what is the lower bound and what is the upper bound when we go across all the data files within that particular manifest file. Okay, so the lower bound within that particular manifest file and the upper bound within that particular manifest file. Since we have got only a single manifest file, that's why we are going across only one single manifest file. If we had two manifest files, if you look at this particular data the diagram, you see this particular manifest list points to the latest version, right? Now it has got multiple manifest files. Okay, so what it would have done is it would have basically stored the lower bound across all the manifest file and the upper bound across all the manifest files, right? That means what it will do, first of all, each manifest file had got its own lower bound and upper bound with respect to the data files within it, right? Now across all these lower bound and upper bounds, it will compare and then it will store the lower bound and upper bound across all the manifest line after scanning across all the manifest line. That's what it's doing. Okay, and then added row count. Basically, we inserted three values. So added row count is three. Existing row count. Did we update it? No. Did we delete it? No. Right? Basically, we did not carry out any merge. Now, in the next session, what we'll do, we'll just carry out a merge operation and see what kind of changes have occurred. First of all, a new manifest list will be formed. First change will be that. Next change, a new set of manifest files may be formed. All right. Data files behind the scenes will be same or may not be same. New set of manifest file will be formed, and information with with respect to that manifest file will be stored in the manifest list. So again, when you store the lower bound and upper bound across all the manifest files, since we have only one manifest file over here, it will scan across this single manifest file and find out the lower bound and the upper bound of it. And how will it find out? Basically, it will scan across all the, since each of these records has got the lower bound and upper bound, it will compare across the lower bound and upper bound of all the data files, and then it will find the lower bound and upper bound of the entire set of data files, okay, across all the set of data files within that manifest file. All right, so do not get confused with this. And then if you look over here, yeah, so manifest length, basically manifest length means is the size of across all this manifest files. So we have a single manifest file, and the single manifest file is actually of this length, okay, it's of this size, okay, it's of this size basically. um yeah, so it's of this size, and then it's referring to the manifest path basically. All right, so these are the kind of information that we kind of store, so do not get confused with this. And then yeah, and then when you get into this metadata JSON exploration, okay, what we see over here is basically we have the we have different kinds of metadata information of the over here. Basically, table UI ID. It's used to refer a unique table ID, uniquely identify the table. So unique table identifier. Okay, and then we have the information of when it was last updated. And the so last column ID, using the last column ID, you will be able to understand that how many columns are there. If the last column ID is 7, then 7 columns are there. If it's 8, 8 columns are there, right? Then we have got the fields, id1, column id1, and column id1 is basically department. And what is its type? It's integer, right? Similarly, column id2 has department name and its type is string. Column id3 is business unit and its type is string, right? So multiple type, multiple this kind of information. So a thousand bit overview about the structure of the table and its data basically. That's what we get from the metadata files, right? And then yeah, so and then another thing that we need to get understand about this, see, it's vt.metadata.json. That means it's the most recent version. Now the most recent version will have reference to an older version even, right? So you see over here, if you look at over here, current schema id is 0, okay, and over here format version 1, format 1, current schema id is 0 basically, right? And within this current schema id 0, you have this information, okay, partition specification, we are partitioning upon what business unit, right? That's what's given, okay. um, if you go down, if you go down, if you go down, if you go down, yeah, schema id is 0. So these kind of information are also there. Snapshot id is there. This is the latest snapshot id that we have seen, right? You have the timestamp millisecond. So yeah, there are multiple kinds of things over them. You have the total file size, is the file size of the metadata file basically, right? How many data files are there? We know it's three data files that we are seeing in the manifest list basically, manifest files basically, right? Delete file, it gets created when you delete data from the files, from the table basically, and we have not deleted, that's why it's not there, right? And added records, after addition of, we have added three data files, right? Why, how it was added? When we inserted three records, so add records is 3, added file size is 306. After insertion of three records, 3066 bytes of data was inserted, right? What is the information? It's sourcing what I told you. The metadata files basically store information with respect to the manifest list, right? It's which refers to the latest version of the data. So manifest list, this is the latest manifest list, right? Snapshot log, like when it was created, when it was updated, right? So metadata log is this one. You see, its metadata log is v1.metadata.json. Okay, all right. v1.metadata.json basically refers to the initial version of the file, metadata file, right? So if you look at over here, we have the format version 1, and then current schema id is 0. schema id is 0. Okay, 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 okay. All right. Hmm. Now if we compare it with this one, v1.metadata.json file, then we'll get to understand about this. Format our id is 1, schema id is 0. Why is schema id 0? Basically you need to understand that. So first see, did we make any kind of changes to the schema? No, right? That's why basically the schema id is 0. Okay, we did not make any changes to the schema, and current schema id is 0. Now if we go down over here, schema id is 0 and current schema id is 0. That's we have seen over here when we first created the table, right? So if you look at over here, current schema id is 0 basically, right? And schema id is also 0, right? If you go down over here and look at over here, schema id is 0 because we did not make any kind of changes to the data, right? And current schema id is also 0. Now if we just alter the table, what you will see over here is schema id and current schema id will change. How will it change? Let me just alter the table. Alter table, which one is this table? One second. This is department, right? This is department. So let me just run an alter table over here, and in just add an extra column. Okay, maybe a column called manager id. And let us see that what changes do we see to the um, metadata file. Okay, we have just altered. Let's see, it's altered, right? Now if we explore, so when you just have altered the table, then a v3.metadata.json file will be there. I'm damn sure about this. Okay, let us just run this one. You have altered the table, right? So you see in v3.metadata, this is the latest one. Now what is the schema id over here? If you look at over here, you see current schema id is 1. That means since you made changes to this particular table, you made alteration of the schema, there's a schema id change. So current schema id is 1, right? And schema id is 1. All right. So whenever you make any kind of changes to the schema of the table, then you have a different schema id being generated, an incremental schema id, right? So initially when you create the table is 0, when you insert values to the table is 0, when you perform merge operation on the table is 0, but when you alter on the table it's 1, then you again perform an alter, it's 2, then it's 3, and so on, right? So yeah, so we have actually explored everything, right? And we have understood the entire set of metadata files that we have in Apache Iceberg. Now in the next video, what we'll do, we'll just start understanding that how to make use of these metadata files in production environment and make our data files in the backend the most optimized, and the entire data pipeline or entire data engineering pipeline basically the most optimized one, the most structured one, and yeah, so it's got a wide or several number of use cases in the production environment. And if anyone starts getting to know these files, then he or she will be the best in the team when if they are using Iceberg basically, right? So yeah, thank you so much for listening to this video. This is a little bit longer video, but it's kind of very informational and very interesting for those people who are kind of looking into the back-end architecture of these table formats. All right, in the most practical way I'm trying to explain to all of you. Okay, thank you so much. Bye bye.